So, what we're going to look at now is about gravity and the acceleration due to gravity. Now, there was a famous experiment made by Galileo. It's actually a thought experiment. It is believed that he didn't actually do this experiment. So, we have two dogs. There's a little dog on the left and a bigger dog on the right. Now, the little dog has a force of gravity pulling him down, and that's his weight. The big dog has a much bigger force of gravity pulling him down because he's got a much bigger mass. Now let's compare these forces. Let's say the force pulling the little dog is 20 newtons and the one pulling the big dog is 800 newtons. So what happens if we took these dogs to the top of the Tower of Pisa and decided to throw them off? Who would hit the floor first? The little dog, which only weighs 20 newtons, or the big dog that weighs 800 newtons? So this was a thought experiment done by Galileo. He wanted to discover if the heavier dog falls faster than the lighter dog. What do you think falls the fastest, the heavy dog or the lighter dog? What he found out was this, that all objects, no matter how much they weighed, would fall to the earth with the same acceleration. So the big dog and the small dog would fall at the same rate with the same acceleration. The value of this acceleration is 9.81 meters per second squared, or it's easy to say 10 meters per second squared. People expected the big dog to fall faster because there's a bigger force pulling him down. The little dog only has 20 newtons pulling him, so he should fall at a slower rate. But gravity affects them both in the same way. However, it's a little bit more complicated than that. When you take air resistance into account, then it becomes a bit more complicated. Let's say in air on the left hand side we have a hammer and a feather being dropped. Well, of course the hammer's going to hit the ground first, the feather's going to float down gently. But if you were to do this in a vacuum, they would both fall at the same rate because they're affected by the same amount. In fact, this experiment was actually carried out on one of the Apollo missions. An astronaut took a hammer and a feather and they dropped them in space on the moon. So that brings us on to the air resistance aspect. So air resistance is a force exerted on an object as it falls, and it's caused by the air, and it's always against the direction of the motion. So basically it's a frictional force. And it basically depends on two factors. One is the shape or the cross-sectional area of the object, and the second one is how fast it's going, the speed of the object. If the object is still, then the air resistance will be zero. The faster it gets, the greater the air resistance. Now here we have somebody falling out of a plane. You notice in part A, the weight is what we've written here as F grav. That's the green line here. Notice that the weight does not change as you go here. Now there's a slight air resistance here. So what do you think would happen here? So here, is it speeding up? Is it slowing down? Is it staying at the same velocity? Or is it zero? Well, the weight is greater than the air resistance, so it will accelerate, it will speed up. In the second one, we have the weight is the same, but if we increase the air resistance to be greater than the weight, what will happen? Will they slow down more? Will they speed up? Will they slow down? Will they stop? Or will it go at a constant velocity? Well, since the friction is greater than the weight, it will actually slow down. And in this case, we have the air resistance is equal to the weight. So what will happen here? Will it speed up? Will it slow down? Will it have a constant velocity, or will it have zero velocity? Well, if these forces are balanced, there will be no change in its velocity. It can't be zero because it can't hang in the middle of the air like that. It would just fall at a constant rate. Here we have the graph, which is a velocity time graph for a parachute who is jumping from an airplane. And let's look at these sections here. They jump out of the plane here. What happens in one? Well, it accelerates, gets faster. In two, the air resistance is so great that basically it reaches a steady speed. And at this point we reach what's called the first terminal velocity. Then at 4 they open the parachute at 42 seconds. So what happens is there's a rapid deceleration. And then at 5 it reaches a new constant velocity with the parachute open. And that's basically the second terminal velocity. You need to know what happens to the projectile. You need to know what happens to the line followed by an object. It's called projectile motion. This one is with air drag or air resistance. This one is without air resistance. There are three things that you should notice. One is that with air resistance it doesn't reach as high. Two, it doesn't reach as far. And in the end it's much steeper than it is at the beginning. In fact, this is a better diagram which represents that.